Alright, so in this video, I'm going to be teaching you guys how to solve these system of equations. A squared plus b squared is equal to 74, which is my first equation. And my second equation is ab equals 35. So I want to find the value of I want to find the value of a and b. So how do I do this? Well, for my solution, what I'm first going to do is recall that if I have something in the form a plus b squared, this is equal to a squared plus b squared plus 2ab. And notice over here how we have a squared plus b squared. Well, we already have the value of a squared plus b squared right over here, which is 74. Meaning that a plus b squared is also equal to, I can plug in 74 for a squared plus b squared, 74 plus 2ab. Now, also notice how a times b is equal to 35. So I can replace a times b with 35, and I get a plus b squared is equal to 74 plus 2 times 35. And 2 times 35 is 70, so I get a plus b squared is equal to 74 plus 70. And 74 plus 70 is equal to 144. So I get a plus b squared is equal to 144. Now, I'm going to take the square root on both sides so I can cancel out the square. So I have the square root of a plus b squared, which is just equal to a plus b, and the square root of 144, which is equal to positive or negative 12. So this gives me two equations. My first is a plus b is equal to positive 12. And my second is a plus b is equal to negative 12. So for both cases. Now, a minus b squared, this is equal to 74 minus 2 times 35. Because if I have something in the form a minus b squared, this is equal to a squared plus b squared minus 2ab. So this is going to equal 74 minus 2 times 35, which is equal to 74 minus 70, which is equal to 4. So a minus b squared is equal to 4. And now from here, if a minus b squared is equal to 4, then I can take the square root on both sides, and I get a minus b is equal to positive or negative 2. So I get a minus b is equal to 2, which is equation number 2. And now from here, I'm going to add up, I can say this is equation 3 because I already have an equation 2. So now I'm going to add equation 1 with equation 2. So equation 1 with equation 3. So equation 1, going back, is a plus b equals 12. And equation 3 is a minus b equals 2. So I get a plus b equals 12 and a minus b is equal to 2. So if I add these two together, a plus a is 2a, b minus b, these two cancel out, and 12 plus 2 is 14. So I get 2a is equal to 14, and if 2a equals 14, I can divide both sides by 2. And these two cancel out. I get a equals 14 over 2, which is 7. Now, I also have equation 2 over here, a plus b equals negative 12, and equation number 4, which is a minus b is equal to negative 2. So if I add equation 2 with equation 4, I get a plus b is equal to negative 12, and a minus b is equal to negative 2. So then I get 2a is equal to, these two cancel out, negative 12 plus negative 2 is negative 14. And if I divide both sides by 2, I get a is equal to negative 14 over 2, which is negative 7. So if a equals negative 7, then we can plug a back in here. If a equals negative 7, then I get 7 plus b equals 12, and b is equal to 5. So if a equals negative 7, then b is equal to 5. And if a equals 7, b equals 5, and a equals negative 7, then b is going to equal 19. So now my final step is to plug this into my original system of equations. So I have a squared plus b squared is equal to 74, and a times b equals 35. So just looking over here, we can already tell that this is not going to work because 19 times negative 7 is not 35. However, let's try a equals 7 and b equals 5. So if a equals 7, then I get 7 squared plus 5 squared is equal to 74. 7 squared is 49, plus 5 squared is 25, and 49 plus 25 is 74. So I get 74 equals 74. And now let's try it in our second equation. A is 7, b is 5, so I get 7 times 5, and 7 times 5 is 35, so I get 35 is equal to 35. And both of these checks are right, so this means that our solution 7, 5 is right as well.